Good afternoon, students. I am Rajesh, and today I will discuss buffer solutions. Today we will see what is a buffer solution, what are different types of buffer solutions, how do buffer solutions work, and how to calculate the pH of buffer solutions. So first of all we will see what is a buffer solution. A buffer solution resists pH change when a small amount of strong acid or strong base is added to it. Now, before we understand this, first let us look at what happens to the pH of pure water when a small amount of strong acid or a strong base is added to it. Now we know that at room temperature the pH of pure water is 7. Now suppose we add a small amount of hydrochloric acid to a sample of pure water. We know that hydrochloric acid is a strong acid. So when we add a small amount of a strong acid to a sample of pure water, we will see that the pH of water will decrease from 7 to maybe 6 or 5 depending on the amount of hydrochloric acid we added to it. Thus, when a small amount of a strong acid or a strong base is added to a sample of pure water, there is a significant change in the pH. Similarly, now consider that we add a small amount of sodium hydroxide to a sample of pure water. Sodium hydroxide is a strong base. When a small amount of a strong base is added to a sample of pure water, the pH of water will increase from 7 to maybe 8 or 9 depending upon how much sodium hydroxide we have added. So when a small amount of a strong acid or a strong base is added to a sample of pure water, there is a significant change in the pH. Now consider if we do the same thing to the buffer solution, what will happen? Now suppose we add a small amount of a strong acid such as hydrochloric acid to a buffer solution. We will observe that there is no change in the pH of the buffer solution. So before addition of hydrochloric acid, the pH of the buffer solution will be the same as the pH after addition of hydrochloric acid. There is no change in the pH. Similarly, now suppose that we add a small amount of sodium hydroxide to a sample of a buffer solution. Sodium hydroxide is a strong base. When a strong base is added to the buffer solution, there is no change in the pH. The pH before addition of sodium hydroxide is same as the pH after addition of the sodium hydroxide. Thus we have noted that when a small amount of a strong acid or a strong base is added to a buffer solution, there is no change in the pH. So a buffer solution resists pH change when a small amount of a strong acid or a strong base is added to it. Now we will see what are different types of buffer solutions. There are two types of buffer solutions: acid buffer solution and basic buffer solution. An acid buffer solution is a mixture of a weak acid and its salt with a strong base. For example, a mixture of acetic acid and sodium acetate is an acid buffer solution. Acetic acid is a weak acid. Sodium acetate is the salt of acetic acid with sodium hydroxide. Sodium hydroxide is a strong base. We can also say that an acid buffer solution is a mixture of a weak acid and its conjugate base. A mixture of acetic acid and acetate ion is an acid buffer solution. Here acetate ion is the conjugate base of acetic acid. Now let us look at basic buffer solution. A basic buffer solution is a mixture of a weak base and its salt with a strong acid. An example of a basic buffer solution is a mixture of ammonia and ammonium chloride. Here ammonia is a weak base, ammonium chloride is the salt of weak base ammonia with a strong acid, hydrochloric acid. We can also say that a basic buffer solution is a mixture of a weak base and its conjugate acid. Thus, a mixture of ammonia and ammonium ion will be a basic buffer solution. Ammonium ion is the conjugate base of ammonia. Now we will see how do buffer solutions work. Now suppose we have a mixture of acetic acid and sodium acetate. This is an acid buffer solution. Now suppose we add a small amount of hydrochloric acid to this mixture. Hydrochloric acid is a strong acid. It completely dissociates in the aqueous solution to form hydrogen ions, also called protons. These protons will combine with acetate ions from sodium acetate to form feebly ionized acetic acid. In this way, the protons are removed from the mixture, so there is no change in the pH. Now suppose that to the same mixture of acetic acid and sodium acetate, we add a small amount of sodium hydroxide. Sodium hydroxide is a strong base. It completely dissociates to provide hydroxide ions. These hydroxide ions will combine with acetic acid and form acetate ions. In this way, the acetate ions are removed from the hydroxide ions are removed from the solution. So there is no change in the pH of this buffer solution. So thus we are seeing that when we add a small amount of hydrochloric acid or sodium hydroxide to a mixture of acetic acid and sodium acetate, there is no change in the pH. Now consider a mixture of ammonia and ammonium chloride. This mixture is a basic buffer solution. Now suppose that we add a small amount of sodium hydroxide to it. The hydroxide ion from sodium hydroxide will combine with ammonium ions to form ammonia and water. In this way, hydroxide ions are removed, so there is no change in the pH. Now suppose that we add a small amount of hydrochloric acid to a mixture of ammonia and ammonium chloride. Protons from hydrochloric acid will combine with ammonia to form ammonium ions. In this way, the protons are removed, so there is no change in the pH. Thus, we observe that when we add a small amount of sodium hydroxide or hydrochloric acid to a basic buffer solution, there is no change in the pH. Now, we will see how to calculate the pH of buffer solutions. To calculate the pH of buffer solutions, we will apply Henderson Hasselbalch equation. For acid buffer system, the equation is pH equal to pKa plus log to the base 10 of concentration of salt divided by the concentration of acid. Here, instead of concentration of salt, we can also substitute the concentration of conjugate base. We know that pKa is equal to minus log Ka and pH equal to minus log hydrogen ion concentration. Now for basic buffer system, the equation is POH is equal to PKB plus log to the base 10 of the ratio of the concentration of the salt to the concentration of base. In this equation, instead of the concentration of salt, we can also substitute the concentration of conjugate acid. Here pKb is equal to minus log to the base 10 of Kb and POH is equal to minus log to the base 10 of hydroxide ions. Now we know the relationship between pH and POH. pH plus POH is equal to 14. So when we subtract POH value from 14, we will get pH value. I hope this topic help you understand buffer solutions. Thank you.